Hi friends, this is one of my first videos in programming. In this video, I'll show you some of my projects which I did while learning object-oriented programming in Python. And in the future videos, if I get some time, I'll be converting these projects of mine into video tutorial so that everybody watching my videos can get benefited if they want to learn. And the video series or the tutorial will be like based on object-oriented programming in Python, like what are classes, what are methods, what are attributes, how we can apply those methods and change the attributes. And those will not be like regular tutorials where we create some employee class, student class. Those will be the classes which I'll be helping you to visualize using opencv, and we can see those objects or instances getting spawned whenever we'll be applying some methods and changing its attribute. We will be able to visualize all those things so that it will be a fun way of learning. Okay, so let me show you some of the projects which I have done using Python, and I think you will get interested in that. So I'll be starting with Python constellation. So a window will pop up, and yes, this is the window. Now whenever I will be clicking on the screen, there will be two instances of a class. Like I have created a circle class, and from this circle class I have spawned the instances. On the click of a mouse event, there will be two instances created, and a method has been applied on it. The method is something like they'll be moving away from the point of origination. Let's see, like this. And when they will be at a certain distance from each other, let's say 100 pixels or something, you'll see that they are interconnected with a line. And what I wanted to create is like something as constellation effect. I think you can visualize it. So with the help of classes, we can spawn multiple instances, and uh, you can see that they are connected to each other. We can feel the constellation effect. You can also do something like this is like a on a click event. You can change it to like mouse drag event. Okay, and also one more thing, like at this instance of time, there are, let's say, you can see in the console there are 14 elements, or let's say 14 instances of this object. Okay, so the 14 instances of the object, I just wanted to show you that whenever these objects are going to leave the screen, you can probably count it like it is 10 object now. Now whenever the object or this instance is about to leave the screen, we'll have to keep a check, and we'll have to remove those objects from an array or list in Python so that we can free the memory or free up the resources. It is a better way of programming, nothing else. Okay, so this is a very good project which I have created for the first time. Okay, moving on to my next project, let's say Python Firebox. A window will pop up, and now whenever I will be clicking on somewhere on the screen, object or an instance will be spawned, and I have applied some methods which will be helping us to create this firework effect. And you can see the color and everything is getting changed, and wherever I'm clicking on that point, the instance is getting spawned. So it looked nice. You can use it in some of the projects. I'll be showing you where I have used it. Okay, so this is a game which I have created. Like it is only a single level game. A window will pop up when I start it, and you can see on the left side there is a player object, and on the bottom left there is a score. The score will get monitored. From the right, the enemy object will get spawned, and they will be approaching towards the left side of the screen, and you will have to shoot out projectile like this. And once it collides with the projectile, you will see that there will be like the enemy will shrink in size, because if some enemies are of all the enemies are of different sizes, of random or different sizes, and on the collision with the bullets or the projectile, it will shrink in size. After 2 shots it will die, like it will get removed from that enemy object or enemy array, sorry. And those blood shots and everything has been created from scratch. Once 4 or 5 instances move from the left side of the panel, of the window pane, you will see that you lost the game, and a score will pop up saying that you have scored this much amount of this is your final score, and this is the total target missed. Okay, and you can see this fireworks effect which I have used from the last project over here. It looks nice as a, like, it can be created on a welcome screen or a bye-bye screen like that. Okay, so on, we'll have to also keep a track of all those objects which we are creating. We'll have to remove them from the list or array wherever we are storing them, so as to keep the memory check. Okay, so the next thing which I'm going to show it to you is this one. So this is a pattern which I have created. You'll see some, after some time, the pattern will become like hollow. Everything, all the circles will become hollow, and it will reappear as solid circle after some time. So it is a very good pattern which I have created all from scratch. I'll be showing you something else also, like this one. It can be used in some games. So an object is getting spawned, and an instance is getting spawned, and it will come down because of a method or attribute, because of a method which I have applied on it, and it will fall down due to gravity. Once collision with the floor, it will get shattered, and its size will also shrink. You can see it, and finally it will disappear from the screen. So we can use it in some of the projects. I'll show you something. This is a game type thing which I haven't completed. It is like on a beginner phase. If you click the left mouse button, the sprite sheet, I have taken this from a sprite sheet, and if you click on the left mouse button, you'll see that it changes the, it's like a superpower. The dog has converted itself into a rolling effect. You can see that. On the right mouse click, you can see it is sitting down. Again, it is running. Again, it is rolling in this way. This can be used in some game. It is a game character. Okay, next thing which I'll be showing you is say, okay, I was creating this game. This can be used as an enemy object, or let's say a player object, and multiple instances can be spawned. You can give it different pattern of flying, and on collision with the player or something like that, you can end up the game, or you can deduct some marks from the, deduct some score from the player. Okay, so these things can be done using object-oriented programming. It is very good way of keeping the code readability, also the maintainability. When we want to spawn a number of objects, a number of instances of the same, from the same class, it is very good and very efficient way of programming. So let's say in this video I'll give you a demo of how we are going to start. I'll be using two packages. One is import cv2, and the second one is numpy array, numpy. Okay, I'll be importing numpy as np. Okay, and I'll be initializing two variables. These variables are like the window width and height on which we are going to draw our instances or objects. Okay, now p1 is like 1000 is the width of the window, and 640 is the depth of the window. Then I'm going to create a background image on which I'm going to draw everything. np.zeros, this will help us to initialize an array, and in this type of np array, first we'll have to give the depth and then the width. It will be of 3 channel. The data type will be the data, I'm sorry for this, data type will be something unsigned integer 8-bit, and let me create a main method which will be called whenever the game starts, not the game, whenever this script starts. So let's say I'll be creating an infinite loop so that we can visualize the object in terms of continuous frames, so that we can feel the video. It will be like, it won't be like an image, it will be like a video. So a while loop will be helping us with that. It will be a continuous loop, and to break out of this while loop, I'll be creating something like this. Let's say first I'll have to create a image show object, image show method, I'll have to call that, and the background image, which has to be, means which will show every time. And to get out of this loop, I'll write a line of code that is, we'll have, if the waiting time is greater than 20 seconds, and the key detected that you have pressed on the keyboard is, let's say Q, then break out of this loop. Okay, now the main thing, we'll have to create a class. I like to use this decorator a lot whenever I write classes. If you don't know about decorator, let me tell you, decorator is like a function which takes an argument as a function or a class and gives and modifies it, gives some added functionality to it. Let's say I'll be creating a circle class, okay, and I'll be decorating it with the data class decorator. Now we'll write the initialization phase, like define self in it. We'll write it in different fashion. Let's say this is one of the attributes of the circle class, like the location where this circle will get, like where the circle will be initialized or will pop up, okay, in the screen, on the background image screen. And y is also the location. X and y are both the location required for a two-dimensional image on a two-dimensional window. So next thing is, we'll be needing something like size, and that will be also integer type. And we'll be needing a color. Color will be of tuple type because it's a 3-channel image. So let me define it first, and I'll be explaining it. So this line of code says that we'll be taking random integer from 50 to 255 for 3 times, and something like this will be created. A tuple of, let's say, 56, 150, and 255. Like this will be created. So this will be like RGB, BGR value for opencv, because opencv accept blue, green, red values. So this is the value of blue channel, this is the value for green, and this will be the channel for red. This will give us the color of the object. Okay, then one more attribute we'll be needing is like the incrementer. This will be helping us to change the attribute. Okay, for the x attribute will be changed using this. I'll be showing you in a minute what I mean to say about this. So this line of thing will be like increment x variable will take any value from 2 to 5, and that will be also random. I'll be needing one more variable, that is the float, and this will be something like this. Let us keep with 6. Like this time it variable will be any float number from 6 to 10. This np.random.random returns you 0 to 1. This will get multiplied with 4, and the 6 will be the starting value. Then we'll be taking an angle, and we'll be beginning with, let's say, 0. Okay, now let's say I create a draw method, and this draw method expects an argument, that is the self argument, which is the object itself. Whenever we'll be creating an instance from this class, let's say the circle class, it will expect something like the self, that is the object itself or the instance which is created itself. It will be passed automatically, and an image. That image I'll be just showing you in a minute what I meant by that. Okay, cv2.circle, this is a method from cv2 library, and it needs a xy coordinate, the point where the circle will be drawn. For double proofing, I'll be creating like integer self.y. It can happen like the increment of y will happen in such a way, like it can take float numbers also, because this will be added into it. So I have created a integer type variable, means whenever I'll be drawing circle, I'll be converting it to int type so that the code doesn't breaks at that point. It needs a radius of the circle, that is the size attribute which we have specified. It needs a color, and also -1 is specified so that we can get solid circles. Okay, not a, if you give it 2, 3 or something, it will be like a ring. It will be like a hollow circle. Okay, okay, so let's check. I will initialize an instance. This is the circle, and this will be drawn at the coordinate p1, which is at the very right, means rightmost part, p1 minus 10. Let's say 10 is the radius of the circle. We want the entire circle to be present in the screen, or else it won't. And let's say p2 by 2. This is double slash is given only for integer division, and let's say the radius will be 10. Okay, now I'll just call the circle dot draw method. Whenever we call the circle dot draw method, the draw method expects a self argument. This self argument is the circle itself. It will be passed automatically. Like the draw method operates on this circle instance. Okay. And this object will be actually, this self is that circle itself. Like self.x is circle.x, circle.y, circle.size, and circle.color. Okay. Now it expects a argument, that is the back image. And this is that back image. Okay, I won't get an error. Okay, now if I just call this in a script way, I always use this if name equal to main, and then I call the main method, and it needs an argument, let's say the background. Now if I just run it in this way, like Python practice, yes, there is the instance which we have just created from the circle class, and it is spawned at the location like P1 minus 10. P1 is this horizontal axis and P2 is the vertical axis. We have created P2 double divided by 2. It is at the center, and P1 minus 10. The 10 is the radius of this circle. Okay, so it has been spawned at this location. Next, we'll have to apply some method over it to see or change the attribute of this instance. Let's say the method is update method, and we'll have to pass the self because it will be operating on this instance. Next, what we are going to do is like if self.x is greater than 0, then we are going to decrease this value of x by self.increment of x. Okay, else we'll just reinitialize, means if it is at 0, we'll be reinitializing it as p1 minus self.size. Great. Next thing is like, let's check the code. Okay, and first we'll have to call the update method over here. If we don't call the update method, the circle or the instance will remain at that position. We'll have to call this update method so that this piece of code runs whenever we enter into this while loop. This piece of code is called. Okay, and the attribute gets changed in every loop. You can see this. See how this circle is moving after every loop. After execution of every loop, the circle's x position is getting changed, the y position is not getting changed. Okay, so let me create something else, like if the self.x is equal to p1 minus self.size, then do one thing, refresh the image so that we don't get that trail of color which has been caused by the previous by that instance, but on the previous location. We can see a chain of color line which has been drawn by that instance of circle, but when we didn't erase it. We'll be erasing it once this circle starts from its initial location, that is the right side. Okay, and one more thing we are going to do is like the self.color, we are going to change the colors, just it will look nice, nothing else. At every instance the color will get, at every repetition, like not the repetition of a loop, but once it reach back to its starting position, the color should change and it would look nice, nothing else. Okay, so this is something like pink color or something, and let's see, once it reaches across the left position, it starts again on the right, and yes, this is like something like light green or something. Okay, so on every repetition, whenever it moves to the rightmost corner, rightmost part, the color changes. So let me create something like a more irregular pattern, like this is like moving in a line, is not interesting, it's not that interesting. Okay, let me start with this, like if we don't need a if loop, we'll just increment the y with let's say we will form a sinusoidal wave, something like that. So I've created that self.angle, and I'll just multiply it with the time it variable so that it gets amplified so that we can see the wave. And on every update loop, increment the angle by, let's say, 0.1. Okay, now let's see what happens. Okay, we expected a sine wave, and that's it. So this is a sine wave, and now I'll be showing you what is the use of class in it. We could have created it simply by putting a lot amount of code, but that won't account for the readability of the code, maintainability of the code. If you want to spawn multiple instances of this sine wave, then it is very easy using this class approach or object-oriented programming approach. Let me show you how. And one more thing I'm going to do is like reduce the size of this, let's say to 5. Only it would look nice, nothing else. Yes, it's okay, fine. It's looking good. So again, let me change one more thing, like the self.y, this location should also change after whenever it starts again from the initial point or something. Okay, so let it start from something like this. It would look nice. Let me see once. Yes, it is starting from the midpoint at the first iteration, like when it is from the at the initial position, it starts at the midpoint. Let's see after this iteration what happens. Yes, the location is changed, like it the sine wave has shifted towards the top. Okay, let us see. Yes, the color has also changed, the location has also changed. Now I'll be showing you what is the benefit of using class. If you want to spawn multiple instances of this, nothing doing, we'll have to initialize a list, and let's say we'll be running a for loop, and for 3 times we want 3 instances of this class, and append it. I've just appended this instance of class, and this will be repeated 3 times. Just change this thing. If you don't change this thing, then one of the instance will be overlapping with the other, and you won't be able to see them. Okay, but just I'm changing the location of all the instances and you'll be able to see them. Okay, you need to change one more thing, is like this. For sir in, let's say, circle. Okay, just update this. Okay, we'll be iterating through all the instances on all the instances and calling its update and the draw method. Whenever we'll be iterating over the instances, these methods will be called, and whenever that instance reaches to the rightmost part after completing of one sine wave, this image will get refreshed because of this line, the color will get changed because of this line, and the position of that instance will also get changed on the vertical axis after it reaches the right end. Okay, so let us see. Yes, 3 instances of the sine wave has been created, and let's see what happens in the second iteration. Yes, the color has changed and also the location has changed to some extent. Let's see for the third time what happens. Yes, again every time it changes, and this is the benefit of class. Like using this approach, we can now in this case what happened is like the bottom one, the 2 are overlapping with each other, so you can see only 2 instances, but there are 3 instances. Okay, so by using this class-based approach or object-oriented approach, you can keep the readability of the code, maintainability of the code, and also spawn number of instances. And you can means it's like very easy to write the code. You can see like we are just iterating over a for loop and just calling their methods one over the other, and everything is getting updated. So that's it for this video. If you like it, just comment it, and if you are facing some problem, just mention me in the comment. I'll be responding back. Till then, bye bye, and if I get some good responses on this video, I'll be coming up with more video tutorial series for my project works. Okay, bye bye.